Okay, now let us talk about limited network volume studies. Limited network means that you have a network of the road which is affected by a single facility, and that facility can be a shopping mall, an airport, a sports facility. Usually, these facilities attract a lot of traffic in the peak hours of the day. So the network around that facility uh, is generating or is having traffic because of, mainly because of that facility. Other things which are around that facility are having less impact than that particular facility. So the network around that facility will be a limited network. These studies are mainly done for traffic impact analysis. So whenever you go for any project, a major project, housing project, airport project, construction of a hospital, so usually in these projects, government will ask you to do traffic impact analysis, and this will be done on a limited network. Now, a limited network may have hundreds of segments, it may have tens of intersections. So, if you try to do it using manual techniques, then you will require a lot of people, it will consume a lot of time. And if you try to use sensors and detectors on a limited network, then again you need a lot of resources and money and technical expertise. So, what we do is, instead of trying to cover the entire network, we cover parts of the network in different time intervals. So we collect a sample from different parts of the network, and then in the end that sample is used to calculate the entire count of the network. So from the sample we do some statistical manipulations, some statistical calculations to cover the remaining part of the network, okay, or to cover the remaining part of the time for which we require the data. Okay, so our aim in limited network study is to prepare an hourly map. So we want to know the hour by hour variation in volume on all the segments of the network. Okay, but we don't observe this directly, we observe a part of it, and then using some calculations we try to find out the hour by hour volume for the entire network. For sampling, you may divide your network into different sub portions. So one entire network can be divided into smaller portions, and these smaller portions should have similar traffic pattern. These small sub portions, what we are calling as sub portions, their traffic patterns and demand patterns should be similar to each other. Pattern meaning their peak hour factor, the percentage of heavy vehicles, directional distribution of traffic. Okay, which direction has more traffic in daytime, which direction has more traffic in nighttime. Pattern should be similar. Values will be different, but pattern should be similar. Okay, for example, peak hour. If one location has peak hour, one segment has peak hour between 8 to 9 a.m., then the other locations in the same portion will have the same peak hour. Okay. Okay, so for sampling, we divide the segments into two types of counts. Control counts and coverage counts. So some of the segments will become control count locations, some of the segments will become coverage count locations. Control counts locations are those locations on which data is taken for the entire for the entire study period. Okay, so whatever your study period is, the data is taken for the entire time. Okay, that is control count. And then we have the coverage count. In the coverage count, data from the entire study period, you select a portion and you spend that portion of time on each coverage point. So for example, your entire study period is 12 hours. Out of 12 hours, you have selected that I will spend 1 hour on each coverage point. Okay, so the main difference between control count and coverage count is the portion of time you are spending on that. On control count, the entire portion of the study period is observed. On coverage count, a part of the study period is observed. A part of the count from the study period is taken. Then there are some guidelines about how to establish the locations of control and coverage counts. First of all, the ratio. So if you have if you have 10 up to 10 coverage counts, then there should be at least one control count. Okay, the ratio of control to coverage count should not go above 1:10, or it can go above 1:20 as well, but not more than that. So if you have like 30 coverage count locations, then in the same portion, then you should have at least 2 control count locations as well. For each type of highway within your network, you should have a control count. So you have like local streets, collectors, and arterials. So one control count for local street, one control count for collector, one control count for arterial as well. And then should have a control count location for each portion of the network which has a different land use. Okay, so you have a portion which is residential. So within the residential area, at least one control count. Within the commercial area, at least one control count. Why? Because traffic patterns are different. So to cover each traffic pattern, we need a control count at that location. Okay, same thing with the type of highway as well. Traffic pattern on local streets not the same as arterials. Traffic pattern on residential areas not the same as commercial areas. So to cover them, to cover this variation of traffic and the pattern of traffic, we need at least one control count on that location on a particular type of highway. All counts are taken on mid-block locations. All counts are taken at mid-block locations. Mid-block meaning between the intersections, not at the intersections, between the intersections. Okay, the part of the road which does not have any entry or exit. Okay, all segments must be either control count or coverage count. There should be no segment which is left uncounted, either counted as a control count or as a coverage count. So you will select 1 or 2 or 3 control counts. The remaining segments automatically become coverage counts. Okay, they should not be left aside. Now if your client says I want the count for the intersection as well, okay, how do you satisfy him? His demand can be fulfilled if you have taken the count on all segments. So one intersection means 4 approaches, right? So if you already have the count from this approach and this one and this one and this one, then you will already satisfy your client. You can tell him this is the total volume on the intersection coming from all the approaches. So you have the volume of different approach, and then you can do the total for intersection as well. This is an example for the campus area, our university campus area, ESA town. So you have the university here, and let's say around the campus this is my limited network. Okay, let's say this one is my limited network. Okay, so you have, for example, Sheikh Salman Highway, you have Sakral Highway, these are arterials. Then you have 16 December, this is a collector, and you have another collector here. Okay, now they call it Youth Avenue or something. They have another collector here. Then you have many local streets, and then this area is educational, this area is residential, here you have a commercial area. Okay, so at least one, so you can divide this entire network into 3 portions: residential, commercial, and educational. And then within them you can put a control count on arterial, a collector, and local street, whichever you have. So maybe in this portion you don't have any collector, so you will put a control count on arterial and a control count on local streets. Then whatever is remaining becomes a coverage count. Whatever segments are remaining become coverage count. Okay, now you see this is a portion of a limited network. It has 7 points in total, 7 segments. One of them, segment A, is the control count. The remaining 6 are coverage counts. Okay, and we have to do the limited network study for that. On this entire network, they need the count of 12 to 8 p.m. 12 to 8 p.m. on a typical weekday. For all segments, they need this 8-hour count for a typical weekday. And they have 2 field crews, or if they have counters, there are only 2 of them. Okay, so at one time they can only record data at 2 locations. Now one of them, the field crew or the counter, will be installed at location A, because I told you what location A is control count, and at control count we need to collect data for the entire period. So whatever the entire period is, we need one team at location A, no exception. And then so there is then one team left which has to shift from point 1 to 2 to 3 to 4 to 5 to 6. So one team will be shifting from point 1 to 6 one by one. Okay, now how much time should I spend on any of these points? I will spend 8 hours on location A, because they are asking for data of 8 hours. Okay, So spending 8 hours on location A is necessary, mandatory, on any typical weekday. So select any weekday and then you spend 8 hours with one team on location A. The remaining team will spend the same 8 hours shifting between all these 6 points. Okay, now you can say I will spend 1 hour on each location by the other team. So you will cover 6 locations in 6 hours, no problem. If you say I will spend 1.25 hours on each location, so again you can cover all these 6 locations in less than 8 hours, no problem. Okay, so the time which you are spending on location A should not be less than the time which you require to cover the other locations. The control count location cannot be less for lesser time than the time you require for the other locations. This is the rule, keep it in mind, and I will reiterate it in the examples as well. Okay, data taken on control count location is starting from 12 p.m. going up to 8 p.m. The complete 8 hours of data is available. For the other locations, they have decided, like I said, you can decide 1.25 hours, you can decide whatever amount you want. Okay, I told you the rule. The rule is this total time cannot be more than the time which you will spend at location A. So they are spending 1 hour on each location. To cover 6 locations, they need 6 hours. Time is spent on location A, 8 hours. Rule satisfied. So on location 1, 12 to 1, count 840. Location 2, 1 to 2, count 625. Okay, so these counts, each of them is as a different location and in different time. And here, each of them same location but at different time. Okay, now I need 8 hour count. 8 hour count for location 1, location A, no problem. Do the summation of these counts, you will get the 8 hour count. Okay, now I need to convert these 1 hour counts into 8 hour counts for other locations. How we will do that, let us see. Okay, so like I said, we always start the calculation in these cases from control count. Okay, so first of all, for the control count, we have the 8 hours of data, total 8 hour volume control count 7067, done. Okay, now from this control count, I will calculate the portion of each hourly volume from these 8 hours. So how much portion of 7067 came in 12 to 1? The answer is 0.117. 825 upon 7067. 825 volume of this hour, 7067 total. So 0.117 came during 12 to 1. Similarly, 0.115 came during 1 to 2, and so on. These factors are known as expansion factors. The portions for hourly volumes are known as expansion factors. Now our assumption was that in the entire portion of the network, whatever happens on one point, the same trend is on the other points as well. So if between 12 to 1, 0.117 of total comes on the control, then in the same time on the other points of the network, 0.117 of the traffic will come as well. So you see here. So let me come here. So 12 to 1, the data was taken on location 1 and the data is 840. This 840 is 11.7%. 11.7% meaning 0.117. 11.7% of the total. Why I am saying this? Because I saw it on the control point. On the control point, I saw that the data of 12 to 1 is 0.117 of total. So data taken on this network at any location will be 0.117 of the total. So between 12 to 1, the data was taken on location 1. So this is 0.117 of the total of this location. So if I want the total of this location, 840 divided by 0.117. 840 the volume of this hour, 0.117 the proportion of this hour. So volume upon proportion will give the total. Okay. So we are using, how did we get 0.117? Hourly volume upon total. So if I give you hourly volume and proportion, then you can calculate total. Okay. So this is how they have done. So this is done for all the locations there. Okay. The time, you need the hourly volume and the expansion factor of that time, you divide it and you get the total. Now let's say your client says give me the peak hour volume at all these locations. Now which one is the peak hour volume? As I said, all trends will be identified from the control location. So look at the control location. Which one is the peak hour? 5 to 6 p.m. is the peak hour because it has the highest volume. Okay. Now if I have to calculate the peak hour volume for the other locations, I will find out the expansion factor of the peak hour and multiply by total. Okay. How do I get the hourly volume? How do I get the total volume? Total volume is, let me show it here. Total volume is hourly volume. Sorry, how do I get the expansion factor? Expansion factor is hourly volume upon total. Okay. And how do I get the total? Total is hourly volume upon expansion factor. So if you have the total, multiply by the expansion factor, you will get the hourly volume. Okay. So expansion factor changes from 1 hour to the other, right? So if you multiply it with the expansion factor of the peak hour, then you will get the peak hourly volume. Total multiplied by the expansion factor of the peak hour will give you peak hourly volume. So I have the totals now. For the control count, peak hour is this one, and this is the peak hour volume. This hour has an expansion factor of 0.163. Okay. So if I multiply the total with this the expansion factor of the peak hour, then I will get peak hourly volumes. Okay. So total multiplied by expansion factor gives you hourly volume, and if you take the expansion factor of the peak hour, then you will get peak hourly volumes. Okay. So this is the case here. Then you have the same, in the same example. Now they have changed the condition. The client is saying, I want to see daily variation as well. I want to cover daily variation as well. So now the control count data cannot be for 1 day, otherwise there will be no daily variation. So control count data has to be for different days, and then in the end we will calculate the average. So we have the different days of the data. Okay. Now we have 6 other locations. Again, you can decide how much time you want to spend on each location. They have decided we will spend 8 hours of each day on each location, each coverage count location. So 8 hours of Monday is spent on location 1, 8 hours of Tuesday spent on location 2. Now remember, they were asking for week day data, weekday. So in one week I have 5 weekdays, so I had to continue the data till the next Monday as well. So you see 2 Mondays here. Okay. So you have the location, and you have the day, and you have the 8-hour data of that day. So obviously, in order to cover 6 locations, I need 6 weekdays. So on the same 6 weekdays, count is taken on the control count as well, control location as well. Okay. Same 6 weekdays. Like I said, there should be matching. Okay. The coverage count data cannot be more than the control count data. So we have to match it. Okay. So somebody else may have finished the control count location in 5 days, but then there will be no matching on the second Monday. I need some matching data for second Monday as well. So this is why I did the data for second Monday. Now if I need the average count for control location, taking an average of this is not a problem. So you take the average of these 6 values, you will have the average 8-hour count for the control count location. Okay. Okay, it is done here. Okay, so this is the average 8-hour count for the control count location. Okay, then I will calculate adjustment factor for each day of the week on using the control count data for each day of the week. So for each day of the week, you take the average divided by the data of that day. Average divided by the data of that day. So average 7350. Data of the day is 7000. So this is the adjustment factor for Monday, first Monday. Then average divided by the data of Tuesday. So the adjustment factor of Tuesday. So you will calculate the adjustment factor of each day. Okay, and then I will apply these adjustment factors on the coverage count locations using the same assumption. If the adjustment factor for control count is this much, then for the same day, adjustment factor for the coverage count will also be the same. Okay, so remember adjustment factor equals average upon the traffic of the day. For the coverage count locations, you have the traffic of the day. You don't have the average, but you have the adjustment factor from the control count. Okay, for first Monday, the daily volume is 6500, and the adjustment factor for the first Monday from the control count is 1.05. So Monday multiplied by the adjustment factor will give you the average. Okay, so the adjustment factor was average upon daily volume. Then the average is daily volume into adjustment factor. Okay, so it's just a multiplication. This data is taken on Tuesday, so multiply by the adjustment factor of Tuesday, and so on and so forth. Okay, so now these are the average 8-hour counts for the coverage count locations. Okay, then we have another variation, same example. Now the variation is the client is saying that 6-day study is too expensive for him. He cannot wait for 6 days. He cannot spend money for 6 days. So finish the study within 6 days. Okay. So why we were doing it in 6 days? Because we wanted to cover 6 locations, and on each location we are spending 1 day. Okay. So if you reduce the time on each coverage location, your overall study will be reduced. So now what they are saying, we spend 4 hours on each location. So to cover 6 locations, I need 3 days. And on the same 3 days, I will collect the data on the control count location as well. So this table is only for control count location. Remember, this table is only for control count location. So on each, the data is for 3 days, and the data is divided into 4 hours. Why? Because on the coverage count location, we are spending 4 hours. So there is again matching. Okay, there should be a match. Now in this table, you see for each 4-hour period, we have calculated the expansion factor. So this is the total for the entire day. From the total, how much for this 4 hours? 42.9%. How much for these 4 hours? 57.1%. Okay. So for now, in the first example, we calculate the expansion factor for each hour. In this example, we are calculating the expansion factor for 4 hours. So it depends upon for how much time you have taken the data. The expansion factor depends upon that. Okay. So for each 4-hour period on each day, I have the expansion factor, and then I can also calculate the average of the 3 days as well, which is calculated here. So the average of the 3 days volume is 6967. The average of 3 days. So the total of the 3 days, and I have taken the average of these totals. Okay, and then using the average and the daily volume, I have calculated the adjustment factor. So you see the adjustment factor of each day as well. 6967 divided by 7000, adjustment factor of Monday. 6967 divided by 7500, adjustment factor of Tuesday, and so on. Okay. Now, the first 4 columns are the data given for the coverage locations. So don't worry about that. The first 4 columns are given. Location 1, data was taken on Monday, 12 to 4. Count is this. This is a 4-hour count. Location 2, again Monday, 4 to 8. This is the count, and so on. Okay. First of all, I will convert the 4 hours to 8 hours. How to convert it? Divide by the adjustment factor, like we did for the hourly volume in the first example. So Monday 12 to 4, what is the expansion factor? 42.9%. So this value divided by 0.429. Okay, and then so on. So this is the expansion factor for Monday 4 to 8. Again coming from here, 57.1%. So now these are 8-hour counts. These are 8-hour counts for 1 day, daily volumes for daily 8-hour counts, right? Now I need to convert them to average. So to convert average, I will multiply by the adjustment factor. Okay, so these 2 values are taken on Monday, multiplied by the adjustment factor of Monday. These 2 values taken on Tuesday, multiplied by the adjustment factor of Tuesday, and so on and so forth. Okay, so this is another example, slightly more complicated one. In this example, we have 10 locations and 1 control and 9 coverage locations. It's still the same network, same portion of the network, so we don't need any more control points, and the ratio is still within 1 to 10, so no other control points are required. We still have the same condition, only 2 teams are available. One team will spend time on location A, the other team will shift between the other 9 locations. And the one team has, like these teams have are collecting data using pneumatic road tubes. So these are tubes which you use on the road, and they count the number of axles. Okay, so each axle is like, so this is one tire, this is another tire, okay, and between the two tires you have, so this is an axle, this bar is an axle. So the pneumatic road tubes count number of axles. We have discussed it earlier. Okay, so for the entire network they need a 12-hour count. For on each location they need a 12-hour count. So what they have done, they have said that we will spend 3 hours 45 minutes on each coverage location. Okay, then we need a 15-minute gap to go from one location to the other location, and then we will spend 3 hours 45 minutes on the other location. Okay, so you can see on each location the data is given for 3 hours 45 minutes, and then there is a 15-minute gap. Okay, and these are the count for the coverage locations. Like I said, there should be a matching between coverage and control count. So for the same 3 hours 45 minutes and for the same day, the time is the data is taken for control count location as well. So table 1, the top table is for control count, this one is for coverage count. Okay, and each value is 3 hours 45 minutes value. So the first, and all of them are axle counts. These are number of axles, not number of vehicles. So the procedure is given here. First of all, convert all values into 4-hour count. So take each of these values, okay, divide by 3.75. 3.75 means 3 hours 45 minutes. So each value will be divided by 3.75. It will convert to per hour, and multiply by 4 to convert to 4 hours. So all these values must be converted to 4 hours. Okay. Second one, for each 4-hour period, using the control count location data, calculate expansion factor, and for each of these days, using the control count data, calculate adjustment factors, like I have done in the previous example. So this is an extra step, this one. After that, you will calculate the expansion factor and the adjustment factor in the same way like I did in the previous example. Then you apply these factors on the coverage count locations, and you will have the average 12-hour count like we had in the previous example. That was 8 hours, but in this case it is 12 hours. Then we need to find out average number of axles per vehicle. For that we have done a manual study. Okay, so in the manual study, for short period, not for 12 hours, we are trying to find out average number of axles per vehicle. So we have some vehicles have 2 axles, 3 axles, 4 axles, 5 axles. So 2 axles in my manual study, 2 axle vehicles were 1100. So maybe it's a study of 15 minutes, 20 minutes. Okay, so in these 15-20 minutes, 2 axle vehicles 1100, 3 axle vehicles 130, 4 axle vehicles 40, 5 axle vehicles 6. To calculate number of axles per vehicle, I will divide number of vehicles, I will divide number of axes, total number of axes observed by number of vehicles observed. Total number of axes observed by number of vehicles observed. Total number of vehicles, easy, 1100 plus 130 plus 40 plus 6, 1276. Total number of axes observed. So these are only axes which you have classified, not observed. How many axes were observed? 2 axes were observed 1100 times. 3 axes were observed 130 times, and so on. So you add all of them, you get 2780. Number of vehicles observed 1276. Number of axes observed 2780. You take the ratio, each vehicle on average, obviously no vehicle can have 2.18 axles, but on average a vehicle has 2.18 axles. Then you have the 12-hour count, the 12-hour axle count for all the locations which you already calculated. So these are axle counts, and then you know axles per vehicle. So axle counts divided by axles per vehicle will give you number of vehicles. For example, if you take the control count here for 12 hours divided by 2.18, then number of vehicles on the control count in the 12-hour period is 5450. So this is how you calculate the number of vehicles using the axles. It needs a manual study. Okay, then we have the concept of VMT. VMT stands for vehicle miles traveled. Vehicle miles traveled. Vehicle miles traveled is the multiplication of volume on the road and the length of the road. Volume on the road, length of the road. Okay, so for example, these are the counts for segments. They are coming from the previous example, and let's say all of these segments are 0.25 miles long. Then you multiply the count with the length, you get the vehicle miles traveled. And if you want the vehicle miles traveled for the entire network, you add all of them. So total vehicle mile count for the entire network is 10,810.5. Okay, what does it mean? It gives you the importance of the highway. Vehicle miles traveled gives you the importance of the highway, because a highway can be important because of its volume or because of its length. If it's a small highway used by very few people, it's not important. If it's a long highway, it's important. If it's used by more people, it's important. So both these things are added in vehicle miles traveled. Now it can be vehicle kilometers traveled as well if you measure the length of the segment in kilometers. And the timing, vehicle miles traveled has a timing associated with it. So these counts are for 8 hours. So vehicle miles traveled is also for 8 hours. Okay. So the units of vehicle miles traveled depend upon the unit of length and the time which you have taken for calculating the volume. Now the flow of the network can be represented in a network flow diagram. Okay, and network flow diagram is a map. In this map you have shown the streets, and the width of the street is as per the volume of the street. So you see this street is narrow and this street is wider. Why? Because of its volume. The actual dimension may be the same. You see here, same street, dimension is changing. Why? Not because of the width but because of the volume. So a network flow diagram, a network flow map shows the width of the roads according to the volume. Okay.